Welcome to the complete Python 3 course, Beginner to Advanced. I'm going to show you in this video 2 hours where you can learn how to code in Python working on practical applications where you can get started programming in Python today. What you're seeing in this video is a free preview of an 8.5-hour paid course. I'm going to give you the first 2 hours of the course here for free because I paid to make the course. And I think you'll love it. Why is Python worth learning? Take a look. This is a search on Upwork.com, the world's largest marketplace for freelancers. These are people right now who know the skill that you can learn in this video. They've worked thousands of hours online, and there's only one person on this page making less than $30 an hour. You'll see people working everywhere in the world: Poland, India, Russia, Sri Lanka, the US, Finland, Netherlands, Malaysia, Ukraine, and many more countries working online using these skills. Python is a very valuable skill to learn, which is why I'm going to teach it to you for free in this 2-hour video. What I'm going to do is cover the following lectures in this video. If you would like the complete course, if you would like to get answers to your questions, would you please go buy the complete course on my website? It's $9, which I've chosen because I think that's affordable worldwide. The complete Python 3 course, Beginner to Advanced, with this thumbnail out of all the courses on my website. If you would like to help me create more free videos like this, I'll give you all the courses I've made, 30 plus online courses just like this for free when you become a patron on Patreon. Go in here and choose the $10 a month, and I will not only give you all the courses I made for free immediately, I will continue making free videos full time. You'll effectively be hiring me to make videos for you. Now, what are we going to cover in this video? I'll explain to you right now each section that will be covered in this video. And if you want to jump around in it, there will be, at least on YouTube, there will be time points to click and you can skip back and forth to these individual sections. If you're on Facebook watching this, you can go to YouTube to get the ability to skip around. First, we will start with a basic introduction to Python. What is Python and why it's a great language to learn if you're new to programming. My goal is for you to be able to start coding in Python by the end of this video. When you see how to install Python, if you haven't installed a way to program in it already, this will obviously help a lot. Windows 10 is shown in case you need that. Then in Lecture 5, into interpreted versus compiled programming language. I learned in C++, which is a compiled programming language. The awesome thing is in Python, you can write a script immediately and execute it. You don't have to compile your program first to run it. Lecture 6, look at creating and running our first Python script. Lecture 7, our integrated development environment. 8 starts with how to share your code and get help with errors. 9 moves into what is a number. Now this might sound really simple, but there's actually a difference in programming between integers and a floating point that you'll want to know. And the nice thing is all of these things you've learned in Python, all these translate into different programming languages. If you can start using this video to code in Python, you can learn other programming languages. And then when you can learn many different programming languages, that'll help you get really good and figure out exactly where you're the best. So some of these things like strings and then string manipulation, many of these are common in different programming languages as well. I remember learning these in high school. Boolean operators in Lecture 12. Lecture 13, what are lists in Python. Lecture 14, dictionaries. Lecture 15, a variable. 16, built-in Python functions. 17, what is a function. 18, implementing arguments into a function. 19, default arguments. 20, keyword arguments. 21, infinite arguments. Lecture 22, return values. We go into 23 with the if-else statement and loops in Python. If you've covered these in other programming languages, they'll be very similar. If you learn them in Python, it'll be easy to pick up another language like C++. Lecture 25, import modules into a Python script. And finally, we will finish with project number 1, building a calculator, where you can actually go through and make a basic Python program by the end of this video, which if you want to have the ability to do what these guys are doing, working online at a good hourly rate, being able to actually finish and write a program within 2 hours of watching this video, I would call that a small miracle. If you would like to continue learning Python, the complete course goes into these things. It covers advanced Python concepts down in all of these different subject lines here. Section 5 in the paid course covers these things you see here. Section 6 has essential modules, then there's section 7, 8, 9 for web development, down here to 10 for the Django web framework, and then that's your entire paid course. If you would like this course and then other programming courses and a bunch of other courses just like it, I'm hoping this will be the best value you've found ever in education. When you become a patron on Patreon, instant access to this and all the rest of my courses online for just $10 a month, plus everything I create new for free for you. Or you can go grab the paid course on my website. Either way, once you've got access to the paid courses, you'll get answers to your questions. Because I'm about to let you go now. Most of the rest of this video will be discussed here by my friend Nick. So Nick is better at Python than me, way better. I hardly know anything about Python, to be honest. I do advertising and marketing, and I learned how to program in C++. So we've collaborated on this video because Nick knows about Python, and I know about online advertising and marketing. So thank you very much for watching this video here with me. Over now to Nick to tell you what is Python.
Hello everyone, and welcome to the Python course that we're going to be doing. My name is Nick, and I'm going to be the instructor for this course, and it's going to be my job to get you completely immersed in the Python programming language. Now, this course is going to be aimed at somebody who may have basic knowledge about what a programming language is, but this would be your first programming language, and this is a great programming language to start with. It does have some limitations, and sometimes this is not the right tool for the job, but a lot of times this offers people who have no experience programming a really great way of understanding what a programming language is and how to use one. So the main differences between Python and other languages like C++ or C or Java is that Python is built around two main focal points, which I believe are code readability and simplicity. So we're gonna jump into the language here in a few videos, but we need to do a few things first. First, we need to discuss what Python is, and then we need to get it installed, and then we can start discussing, what's an interpreter, how do you run a Python script, and then get into the language itself. Now, the language is different, but it's easy. Once we get past an understanding of how the programming language works and the syntax and all the different stuff you can do with it, we're going to move on to actually programming real applications and showing you guys different practical applications of the Python programming language. So, for instance, we're going to be building a website. We're going to be building a web scraper and a graphical utility. We're actually going to be building multiple graphical tools because there are a few different graphical or GUI, GUI, whatever you want to call it. There's a few different frameworks for Python that we could use. So we're going to explore 3 of them. So right off the bat, here's a fun fact. If you didn't know, Python is actually named after Monty Python, who's made some great films. So if you haven't seen Search for the Holy Grail or The Life of Brian, go do it. They're great movies, which is completely beside the point. So Python is actually a pretty old programming language. It was first introduced in 1991, which makes it 25 years old. There's 2 current versions. Now, this may be confusing as well. So there's a Python 2 series and there's a Python 3 series. The Python 2 is currently at 2.7.11 and the 3 series is at 3.5.1. Now we're going to be using Python 3 in this course. However, Python 2 shouldn't be much different if afterwards you want to explore using Python 2. That's completely acceptable. So now, as I said, Python is based around simplicity and readability, and this means that when you look at Python code, it's all indentation based. So if you looked at another code like Java, you'd see a lot of curly braces and brackets and a lot of things that are just there to confuse the novice programmer. Python is based on indentation, so you don't need to wrap blocks of code in curly braces, and you guys will see what I mean coming up in the next few videos. So that's all we're going to talk about today. I hope you guys enjoy this course and find it useful. There's a comment section to the right for each video. If you guys ever feel that you're not too sure on something that I explained, or maybe you had some input in addition to what I explained, feel free to use that. So yeah, let's get started. So the first thing that we need to do to get into programming in Python is installing it. So let's go ahead and discuss about the 3 different ways that you're going to be installing it. First, we're going to cover Mac because that's what I'm using, and so it's easiest to show you how to do it. So what you're going to do is open up Terminal, which I've moved out of that folder and put right here. Now, if you haven't installed Homebrew, what you're going to do is run a Ruby command. It's going to download and set it up. So basically what Homebrew is a package manager that you can use to install a lot of packages. So if you're used to Linux, basically on Linux, if you want to install a package, you don't need to go all around the internet and search for packages on websites and then download from shady sources and get viruses. That's just a bad construct of computer operating system. But unfortunately, that's how Windows works. And so I'm going to show you guys the right way to install in Windows as well. Using Linux or OS X, you're going to be installing through Terminal. So first, set up Homebrew. This is how you do it. Come to brew.sh, and it's going to give you this line of code here. You just paste this in Terminal, run it, it's going to install Brew. Once you've got Brew installed, what you're going to do is run brew install Python. Now, that's how easy it is. OS X does ship with a version of Python, but it's okay. But the version included in OS X is 2.7 series, and I think it's actually an old release. I think it's like 2.7.5 or something like that. So it's pretty old. At least I think it was that. We can actually run Python version here. So the version that OS X, El Capi 10 ships with is 2.7.10. When you run brew install Python, it's going to install Python 3. That's the command that we're going to have to be using because there's already a Python version installed. So we're going to be using Python 3, and you can check the version. We've got 3.5.1. That's the version that Homebrew is going to install for you. Now, similarly, if you're on Linux, what you would do, there's a few different ways because there's a few different package managers. So if you're on Arch Linux, I don't think you're going to need help setting it up. And actually, a lot of Linux distributions have Python and Python 3 pre-installed. So you can just run Python --version and Python 3 --version and see what version you have installed. You might need to upgrade it. It might be fine. If you have 3.4, you can follow along with this course. I don't think there's that many differences between the 2 versions, and there's definitely not code breaking differences, so that shouldn't be a problem. However, if you do notice that you're having a problem, you could upgrade the version of Python either through using a repository or otherwise. If you're on Ubuntu, you're going to be using the apt-get command. So you'd run sudo apt-get install Python 3. And that's going to install Python 3 for you. If you're on Fedora, I believe used to be Yum. I think it's DNF now. Yeah, so let's just review exactly what commands you're going to be using. I think it's like DNF install. So you can still use yum, I guess. Okay, so you can use yum to install. So what you're going to do is you're going to run sudo yum install, and then I believe the package is just called Python 3. Python 4 is going to be pretty amazing, but right now we're using Python 3. So, yeah. So there we go. Now, if you're on Arch, and I said I don't think you need any help getting it set up, but just for, if you are new to Arch, you'd run sudo pacman s and then Python 3. But again, Python 3 should be pre-installed. So you shouldn't even need to do any of this, but if you do, that's how you do it. Now on Windows, you do need to go download a file from the internet and run it. The difference between what I said before and what I'm saying now is this is not a shady location. So what you're going to do is go to python.org, go to the download sections, and if you just hover over this, it's actually going to show you a drop down, and you can choose what platform you're on. So you would choose Windows. And they actually have 3.6. Which we're not going to be using because this is an alpha, I believe. So click latest Python 3 release, Python 3.5.1. It's going to take you to this page and basically give you a change log and whatnot. If you go down here, make sure you get the version that's compatible with your system. If you have a computer that is not obsolete, it should be running a 64-bit operating system, which means it has a 64-bit processor. So you would download this one right here, Windows x86-64 executable. And what that's going to download is an exe file which you can use to install the program. If you're running a 32-bit system, you're going to download this one, just the x86. And yeah, just install it. Now there is one note on the installation. When you run the installation, there's going to be a certain step where you have some checkboxes, and one of them is going to say add Python to the path variable. Make sure that's checked, because if it's not checked, if you try to run Python in the command line, you won't be able to because it won't know where to find this mysterious Python command. So by checking that box, basically it tells Windows where the Python binary file is located. So you want to make sure Windows is aware of where that file is. And that's all there is to installing it. To confirm that you've got it installed, open up a command prompt or terminal and just type Python 3. And it should drop you down into the interpreter, which we're going to be discussing in the next video.
Hello everyone. Last video, Nick touched briefly on installing Python on a Windows system, and I assume many of you are using Windows as well, so I'm going to go ahead and walk you through the installation real quick. So you want to go to python.org, and we're going to hit the downloads button. And then what we're going to do is we're going to download the latest version of Python 3 for Windows. And then your browser should automatically download the installation, so we're going to go ahead and click on that. And actually, this is not what we want, because I know for a fact I have a 64-bit system. I don't know why it automatically downloaded the 32-bit version of Python. So I'm going to go ahead and cancel out of this. And if you're curious whether or not you have a 32 or 64-bit operating system, you can right-click, go to System, and it will tell you which operating system you have. So we have a 64-base processor, and we need a 64-bit version of Python. So we'll go ahead and click on the Windows link here instead of hitting the download button. All right, so that's beta. Let's go ahead and click on 3.5 release again. And what we're going to do is scroll down a bit. Now let's do the Windows x86-64 web-based installer, and this should include both versions of Python. Try that one more time. There we go, 64-bit. So you want to go ahead and click this box down here that says add Python 3.5 to path. This is so we can issue commands to it via the command prompt. So we want to make sure this is clicked. We're going to go ahead and hit install now. Click yes. And then this should install everything you need to follow along with the course. So thank you for taking the time to watch this video. I just wanted to do a quick video showing you guys exactly how to install it on Windows, just so you don't have any problems getting set up for the course.
So the interpreter, and this is going to be a short video, I think, but we're basically going to talk about the difference between an interpreted programming language and a compiled programming language. So, and this might be a little adept for the novice programmer, but just stick with us. Again, if you have any questions or not sure if you completely understand it, there's a discussion section to the right of this video. Yes, should be right to the right of this video. So use that, and I will try and clear up any confusion. So first, with a compiled programming language, you write your code and you save it into this file, and you can't run that file yet. Let's say you're writing C++ code. So you write a function, you write a script that will do something. If you try and open that file with the .cpp extension, which is for C++ files, it's just going to open that in a text editor or a code editor because that's not an executable file. What you need to do with a compiled programming language is once you save your file, you need to compile it into a language that the computer can read. So binary, the ones and zeros. And by compiling this file into an executable file, then you can double click it and it will run. So if you're on Windows building executable files for Windows, they will have a .exe extension. If you're on Linux, I don't believe they have an extension. So the difference here is with Python, when you write a script, you can instantaneously run that script without having to compile it into binary. And because we can do that, what's actually happening is when you run the Python command, you're not running the file standalone. So when you compile a programming file into a binary file, you can just type the name of that file in the terminal or command prompt and hit enter, and it will run that program as a standalone program because the computer already knows how to run it. But when you run Python scripts, you're going to run it with the Python command and then the name of the file. And what basically happens is you're running the program Python, which is interpreting your code and running that. So what happens is it does compile into binary, but it's called just-in-time compilation. And what that does is every time you run it, it's going to parse all the code and it's going to convert it into a temporary file and then run that temporary file. So let me break out of this. There. So how you would run a script, and we're going to talk about that later, but basically how to enter the interpreter on its own, you just type Python 3 to use the 3 version of Python. You can see the version we're using, Python 3.5.1. So basically in the interpreter, you can run real-time code. So if I were to type print hello world, it's going to instantaneously run that line of code. If I run 4 plus 6, it's going to return 10 because that's the sum of 4 and 6. And so the interpreter is great to use if you want to test something really quick, if you want to debug a few lines of code, or if you just want to see if something would actually work. So we're going to be starting out using the interpreter, but as things get a little more complex, we're going to get into writing scripts and executing those scripts. So now we need to learn how to run a Python script. So let's go ahead and create a Python script and learn how to run it. So I'm going to be doing this in terminal completely. We will discuss other options later. What I need to do first is change directory into PyCharm projects, and there's nothing really in here. So I'm going to create a file using the Nano text editor. You guys don't have to follow along. However, if you want to, that's great too. I'm just going to call it test.py. Now, all Python scripts need to have the .py extension. So what we're going to do is just a simple script. It's going to print hello world. So I'm going to Control O to save and Control C to exit. Control X to exit. All right. Now, if we just type test.py, you'll see Bash doesn't know what to do with this command because test.py is not an installed program. So what we need to do is run Python-3 test.py, and it will return the result of anything in that script. So that's how to run Python scripts. In the next video, what we're going to be doing is setting up an actual work environment using an IDE and get you guys all ready to start with the basics. All right, so what kind of work environment do we need to be efficient at programming with Python? The question can be posed for any programming language, really. And so the answer is usually going to be the same. I mean, feel free, if you want to open up Notepad on Windows or some basic text editor and write a script and go over to the terminal or command prompt and run it. However, that's not efficient for a variety of reasons. So what we're going to be using is an IDE, which stands for Integrated Development Environment. And we're going to be using JetBrains PyCharm. Now, PyCharm is free I spelled that wrong. Just go to Google, search PyCharm, and click on the link there, which is from jetbrains.com. And you can download it. Now, when you get to the download screen, you're going to get a professional or community version. Choose the community version that is free. It's completely fully featured as far as I can tell, and that's the one that we're going to be using in this video. Now, alternatively, I mean, you can go have a look at other IDEs for Python, but I find that this one, it just works really well. It's simple and it does everything that we need it to do, and it also has some advanced features which we may look at some point in the future. So go ahead and download the installer for your platform. It does require Java as well. So you can just open up Google and type download Java. And it's going to take you to java.com/download. If you click that link, just click it, download the appropriate version for your system. And once you have that installed, then you can install PyCharm. So let's take a walk around PyCharm right quick. So this is going to be the first screen that you see every time you start up PyCharm. The first launch screen is a bit different. You can choose a theme and whatnot. All that is relevant, really. We're going to create a new project. It's going to be pure Python. Now there's also other options here if you want to start a Django project, etc. We're just going to start a Python project here. And we're going to choose version 3.5.1, which is also going to tell the IDE here where to find the binary files to run Python. Now we're also going to name the project here. So first program. And this is just going to be the name of our project. It's going to create a folder called first program, and this is how we're going to identify it within here. So along the left hand side here, this is the project view. So let's go ahead and right click and create a new file. Now additionally, you can create a new directory, a Python package, and a bunch of different file types here. We're just going to choose Python file, and I'm going to name it main, which is going to name it main.py. And here we can start typing our script. So again, I'm just going to use the hello world example. And that's all it's going to be. Now I'm going to save it. Keyboard shortcuts are going to take you a long way if you're going to become a programmer. So I expect you know some already. If you don't, on Windows and Linux, Control-S saves a file, and on OS X, it's Command-S. So you don't have to always go through the menus and stuff. But let's have a look through the menus. If you want to create a new project, a new file or directory, you can open one, etc. You can actually access the settings by going to default settings for this project and a bunch of different options down here that we don't really need. If you go to edit, you're going to see you can undo, and it's also going to show you the corresponding keyboard shortcuts for each one of these options. So this is Command Z, and that's going to undo whatever action I previously did. This is also going to be useful if you're going to become a professional programmer. Same is true for copy, paste, find. We're going to be discussing find at some point. I mean, it's a pretty powerful command. You can find not only in the current file, but your entire project. If you want to look for instances of a variable or string or something, you can actually search through the entire root directory of this project if you want. If you go to View and go to Tool Windows, here is what we're looking at here. Project, if we select that, it's going to, it should hide that. Yeah, so it hid the project sidebar, so we're going to leave that open. Now we can also show favorite, structure, etc. If you have version control set up, this will not be disabled, and you can use that to perform version control actions. We're going to open up Python console here. And here, we can actually run Python code if we wanted to say 5 plus 5, and it's going to return that. So this is the interpreter itself. However, if we want to actually open terminal, we can open a terminal here, and here we can just type Python3 main.py, and it's going to run what we have up in this file right here. Now, additionally, we have a run right here. We can set up a run configuration here to actually, every time we hit the run, it's going to automatically run our project. So let's go ahead and hit the plus sign, choose Python, and it's going to be called Python run. The script is going to be Python 3. Or the script is going to be the actual Python script that we want run. So this is going to be main.py. Script parameters, this is if we're passing in any arguments or anything. We're not going to. It's already found the Python interpreter because when we set up the project, we chose the correct Python version. This is going to be interpreter options. We're not going to be using any. And that's all that we need to do. So let's go ahead and click apply and then run. And it's going to run the script. Output that, and then it says it finished with exit code 0, which is completely normal. So every time you want to run, if you have this little section opened here, just hit that play button, the run button there, and it's going to run the code in real time. So make changes, hit Control-S, and then run the code right there. This is the most efficient way to run a program in an IDE. You don't have to switch back and forth between windows and stuff. So this is the prime reason that we're going to be using this IDE for the sake of this course. Again, feel free to have a look at some others, but I recommend if you're a complete novice to any of this, just follow along exactly with what I'm doing and you shouldn't have a problem. However, if you do, there's a discussion section to the right of this video. Use it, let me know if you have any trouble, and I'll try to clear it up. So with all that said, we are finally ready to actually get into the language itself. All right, so before we actually get into functional programming or object-oriented programming for that matter with Python, we need to discuss some basic types and then variables and then some other stuff. So in this video, we're going to be covering numbers. So what is a number? Well, I'm sure you guys know what a number is. I'm sure we've all been through grade primary and 1, so we're all familiar with that. Now, there's two different types of numbers. One's called an integer and then a floating point. The floating point is basically any number that has a decimal included in it. So let's go ahead and write out some numbers on the screen. Now I'm going to be using the Python console down here for this video, so watch down there. That's where stuff's going to happen. So for an instance of a number, we can just write a number. It's going to appear in the console or the IDE or whatever, has syntax highlighting that you're using. It's going to show as blue, or it should. Actually, that really depends on your color scheme that you've got going on. It's going to show a specific color. Now, we can just use numbers in Python just by writing the numbers. And if we hit enter, it's going to print out 5. Now, with numbers, we can perform mathematical operations on these numbers, as you saw in some of the previous videos that we've done so far. So I could write 5 plus 6, and we're going to get a response of the sum of 5 plus 6. Now, what would happen if I wrapped these numbers in quotations? So let's go ahead and write 5 plus 6. If you think that this will produce 11, you're wrong. It's going to produce 56. And you might be thinking, hold up, 5 plus 6 does not equal 56. You're absolutely right. Not in math, however. When you're concatenating strings, it does. So basically, when you wrap something in quotations in Python, Python is going to treat it as a string, not a number. So if you're trying to perform mathematical operations, just remember, don't wrap your numbers in quotations. Now, additionally, we can use floating points to perform math operations. And you can see it returns a floating point. Now, if we ran 5 plus 5.5, it's going to still return a floating point. However, the last, it's 11.0 because we've passed it, decimal floating point numbers, and so it's going to return with one because that's just how it works. Now, we're going to talk about how to convert different types of types, I guess. These are called types. A number is a type, a string is a type, and right here we've shown both numbers and strings, and we're going to cover strings in the next video, but for right now, let's say, well, I have some numbers, but they're wrapped in quotations, and I still want to perform mathematical operations on them. How can I do that? So basically, in Python, there's a built-in function called int, which will convert a string to a number if that string contains only numbers. So let's look at a correct usage of int and then an incorrect usage and see the output for both. So let's say I have the number 5 wrapped in quotations. What I'm going to do is wrap that in the int function. And this is also how you write a call to a function in Python. And then I'm going to perform a mathematical operation on it with another number wrapped in quotations. Now, this is not going to produce 57. In fact, it's going to convert both of those into integers and then perform the math operations on them. So that's how to add up different numbers that are contained within quotations. Let's have a look at trying to convert text to an integer. So let's write int, and let's write hello, let's hit enter. As you can guess, it's printing out an error because there's an invalid literal for int with base 10. Basically, what that means is we've passed it something that is not an integer. So think of this function basically as it takes whatever you put into the function, it removes the quotations, and then returns that. Same if I just type this, Python's going to freak out because it doesn't know what hello is, because this is going to be interpreted not as a string, but it's going to be interpreted as computer code. And we're going to get more into strings in the next video. All right, so what is a string? Well, a string is any text that you want to be treated as text within a program. So again, we need to talk about a few other things that we're going to be talking about actually a few videos from now. But for right now, just try and follow along. So this is a string because it's wrapped in quotations. And if we hit enter, Python's going to say, hello string. Now, you can also use single quotations here to do the same thing. So basically you have two options, either using double quotations or single quotations. Now let's say you want to have a word in your string that let's say you need to have a word in that string of text which contains an apostrophe. So let's say we wrapped it in single quotes and we say, don't do that. Python's going to freak out about that because what it thinks is happening is that we're starting a string here, we're typing 3 letters, and then we're ending the string, and then it doesn't know what to do about all this. It's saying, well, T do that, I don't know what that means. There's no variable and there's no function that I can perform on this, so I'm just going to freak out and give you a syntax error. So what you would need to do in order to print out don't do that is you can just wrap it in double quotations and then just type don't do that. And as you can see, when I print it, it's going to keep that intact. Now, alternatively, let's say you want to quote somebody. So let's wrap it in double quotes and say, she said, I want this. And then close it and close it. Again, it's going to freak out because what it thinks that we're trying to do is start a string, say she said, then end the string, and then it's going to freak out over all this because it doesn't realize that this is part of that string because we've explicitly told it to end that string here. So what you would do in this instance is just wrap the entire string in single quotations. So she said, I want this. And as you can see, it's going to print it out correctly. Now, alternatively, what if she said something that had an apostrophe in it? So let's try and cope with that. So she said, don't put that there. Again, it's going to freak out because we're starting the string here. We're adding a single quotation, which it's not interpreting as the end of the string. In fact, right here where this apostrophe is, it thinks that's the end of the string. So it's treating this like a string, and then this as constants or variables or whatever, and it doesn't know what to do with them because we're not telling it to do anything. And then these just random quotations here. So what we need to do in this instance is we need to learn about escaping certain characters. So let's write it out first and then I'll explain it. So what we're going to do is wrap it in single quotes, and we're going to say, she said, don't do that. And what's happening here, let's hit enter. That's not what, let me print that out. It's just returning what we wrote there. There. So we print that out, and what this does is the backslash here tells the next character to be interpreted as text, regardless of what it would normally be interpreted as. So rather than this trying to end the string, Python knows at this point that we want this to be printed out with the string and not end the string, but just print it out as a single character. And so that's what it's going to do. So there's times when you're going to need to do each of these in your Python code, and so that's how to handle strings and what they are. Again, a string is just a series of characters which is interpreted as text, and you can print it and you can manipulate it. We're actually going to get into string manipulation in the next video. All right, so what are some of the fun things and useful things that we can do with strings in Python? Well, there's a few concepts that I want to talk about here. So what we're going to do is go ahead and open up a Python interpreter. You can do this in PyCharm by going to View, tool windows and then selecting Python console, or you can open up terminal and type Python 3 and hit enter. However you enter this, if you want to follow along, that's probably helpful, because I find if you're told how to do something, you kind of know how to do it, but if you actually do it yourself, you have a better handle on what happens, and you're more likely to remember how it works. So from here on out, basically what I want you guys to do is to follow along with your code and do everything that I do. So with that being said, one of the first things that we're going to do is, in a previous video, when we were talking about numbers, I showed you how to convert strings into numbers if the only thing in that string were numbers. So this is going to be kind of the opposite. Let's say you have a few values. Let's say you have the number 6, right? And you want to print out this costs $6. You can't just well, actually, first we're going to talk about concatenating, because you can't do that in Python. I'm going to show you how. But first, let's learn how to concatenate a string, which means how to glue multiple strings together. So we saw this actually in the numbers video as well, when we tried to add numbers that had been identified as the string, or the string type. And what it did was concatenate the numbers, and it made 5 and 6. When you add them together, it made it equal 56. And so that's, you're gluing strings together. So I'm going to say hello, and then pop out of that string, put a plus sign, and then in this string I'm going to type Nick. Now what's going to happen is it's going to print out hello Nick, because I'm concatenating these two strings. You can also do this with however many instances of strings you want. So if I really wanted to get a little bit convoluted, I could do this. And this would print out hello using 5 strings all concatenated together. Now what happens if I want to say this costs $6? Well, because part of this line is an integer, it's going to try and use those plus symbols to perform a mathematical operation rather than printing out a string. Actually, it's the opposite. It can't convert the integer to a string. So it knows that we want to concatenate some strings together, but it's like, well, hey, hold up, this is not a string. I don't know what to do with this. So what we have to do is use the string function, which is similar to the int function. So how we do that is this costs $6. And what this is going to do is it's going to convert the number 6 to a string so that it can be used. Now you can also perform mathematical operations within the string parameter, I believe. So let's test this out. This costs, let's go 6 plus $5. Let's hit enter. So it can perform mathematical operations within that parameter. It's going to convert the sum, or the result of whatever mathematical operation you're performing on it. It's going to convert that to a string, and then use that string to be concatenated with the other strings that you're working with. So that's how to use the string function. And maybe this doesn't seem like it's going to be important, or maybe it does, but you're like, well, how often do you use this? We're going to see, because when we get into defining some functions, we're going to be using both strings and integers to return certain information, and so this is going to be important at that point. So that's how to convert integers to strings. It will also work for any other type. So if you have true, we're going to get into that after actually, but we're going to be using this string function again at a later point. Now what happens when you want to do the opposite of concatenating strings? So think of concatenation. I'm not sure if that's the appropriate term. Think about concatenating two strings as, actually, let's look that up. Now, it's going to open up Xcode. Let's just go into Google here, because if I'm saying that wrong, I want to know. Yeah, okay, concatenate. Good stuff. I'm not sure if you guys heard that, but I'm using that word correctly. Good stuff. All right, so anyway, back to the code. That's how you concatenate two strings together. What happens when you want to do the opposite and you want to split strings apart? So let's say we have this string. Like this. So we're going to say hello. We're going to separate that word from the other word with a colon so that we actually have a character that we can use to split. So what we're going to do is after that string, we're going to put a dot. We're going to call a function split on it. And the split function or method takes one parameter. Well, for the sake of this video, it takes one parameter, and that's where you want the string to be split. So we're going to split it at the colon there and hit enter. What it's going to do is it's going to create an array with all elements that had been split from that point. So for instance, it split it into two items in the array, but let's say I did this. It's going to have an array with 3 values in it. And then we could reference those values by its index number. So this is going to be a bit more complicated. Let's say we're splitting it at this. So let's concatenate that. Let's say my name is so we want this to print out my name and not hello world and not anything else. So what we're going to do is put 2 square brackets and the number 1. And it's going to say my name is Nick. I'm not sure if that's a bit too complicated, so I'm going to try and explain it again from the beginning. So we have a string. We have it say my name is, and then a space, and then we concatenate it with the result of this right here. So this can be broken down into a few parts. Here's the string that we're performing the split function on. Okay. Then we're calling split on it, and this is going to turn this string into an array with 3 values, each with an index. It's going to split it into hello, Nick, and world, and stuff those values into its own array. And then we can access the result of this by using an index number here in square brackets. So we're calling the index number 1. So hello would be 0, Nick would be 1, and world would be 2. So what's happening is it's printing out my name is Nick. Now you might be thinking, shouldn't it be printing out my name is hello if we're using the number 1 here? This isn't so much Python, but it's a concept in programming in general. No. So 0 equals 1. If you have an array, the first item in it you think would equal 1, but it actually equals 0. And we'll talk more about arrays, which are actually called lists in Python. We'll talk more about those coming up in, I think not the next video, but the video after the next one. So that's how you can manipulate strings in a very basic way. We might expand on this in the future. We actually probably will. So next, we're going to be talking about Booleans. Welcome back, people. In this video, we're going to be talking about Boolean operators. So what is a Boolean? Well, basically, it's not just a Python-specific concept. It's a programming concept in general, and it consists of 2 items. One is true, one is false. Now, in a lot of programming languages, you typed true as T-R-U-E and false as, you know how to spell those, but you'd spell them all lowercase. Python's different, so let's explore that a bit. Going to open up terminal here and launch a Python 3 console, and we're going to just print out true, and it's going to return true. This is not in quotations. Make sure when you're typing true and false for truth checking that you're typing true and false and not like this, because that will return a string, which is true. Yeah. So let's talk about what these operators do basically, and we're going to get into comparison operators a bit later, which is like checking if something is equal to something or more or less than, or if it even exists, or if it's a certain type. And so you can basically perform different actions on different types of data, and that's why it's necessary to do some fact checking with that. So we need the true and false in programming. However, we can explicitly declare true and false like we've just done by just typing true or false, or we can generate it in other ways. So let's have a look at some of the ways we can generate a true or false. So let's type 5 equals 5. That's true. Now, when you're comparing two objects and you're checking if they're equal to each other, you can't type that because the single quote, the single equal sign there is used for a different purpose in programming. It's used to assign a value to a variable, and we'll go over that here soon as well. So when we're comparing to check if two numbers or two strings are equal to each other, we need to put two equal signs. So you'll see that returns true. So let's go ahead and 5 equals 4. That's going to return false because, of course, we've all been through grade 2 math, and we all know that 5 is a little larger than 4. Now you can also do this with strings and also without using equal signs at all. You can actually type 5 is 5, and that will return true. And you can type 5 is not 5, and that will equal false. So basically you're saying 5 is not 5, and Python is saying, well, that's false. So you could type 5 is not 6, and that will return true. Now, again, you can do this with strings as well. So you can type this is this, and this is going to compare both of these strings to see if they're equal to each other, and it's going to return true because, yes, it is. Now, we can also do this. True is true will return true because, of course, true is true. Now, that last one is a bit of a obvious result. So let's go ahead and compare this with this. If you think this will return true because we're comparing true and true, the results will not be as obvious as you expect because one of them is a string and the other one is a Boolean operator. So not only when you compare two items is it checking if the value is equal, it's also checking the type of data that it is. So if we wanted to make the above statement return true, we would have to convert true into a string. So just like you would convert a number into a string, you can just wrap the Boolean operator in the str function, and it will convert it to a string prior to the comparison, and then it will return the result of true is true, which equals true. Now, true and false, again, they're going to come up in the if-else statements, because that's where we're really going to do some error checking and make sure things are set and that they're not just not equal to each other. And you're going to see more practical uses of Boolean operators later on. But this was just to show you guys what true and false is. And again, you should already know this without a programming background. So, in the next video, we're going to be looking at Python's version of arrays, which are called lists. All right, so let's discuss lists and what they are in Python. So let's open up terminal again and launch a Python 3 console. So if you do have experience with programming in other languages, let's say PHP, you know how to create an array and what an array is. For anybody else, it's a way to keep data organized and within one construct. So we're going to go ahead and define an array, and how we do that in Python is just open up and close square brackets. And then in them, we're going to have some items, and those items are going to each have their own index number within the array. So let's say we're making a list of things that I like. So I'm going to type movies, games, and of course, Python. Now, what this becomes is a list that has 3 indexes, and we saw earlier when we split a string apart that created one of these, and so you guys already know how to access items within this array. However, if you forgot, we're going to go ahead and do that. So basically, I can put an index of 0, and it's going to print out movies. Now, if we put that in a print statement, we're going to concatenate it. I like, and then, oh, did I just lose that? Oh, cool. All right. And we're going to end it there. So let's go ahead and print this out. It says I like movies. If we change that index number to 1, it's going to say I like games. And if I change that to, oh, not 3. So I like Python as well. Now, what happens if one of these are a number? Let's say I replace this with a number 16. Let's say I like 16. Let's go ahead and change this index to 1 and hit enter. It can't convert the integer to a string. So what we would do is if we were trying to print, and this specifically printing out an array and then choosing an index at time of array creation or list, that's impractical and we're never going to do things that way. So what we just saw, this error message, doesn't really matter. Basically, again, if you're trying to concatenate a string with an integer, it's going to freak out because it doesn't know how to do that. So that is what a list is, just a way to create a collection under one variable name. And when we discuss variables, we'll revisit this so you guys can see what I mean. In the next video, we're going to be talking about dictionaries. And basically, these are like, in JavaScript, you can create JSON objects, and that's basically what they are. So let's get into that. So let's get into dictionaries, and that's going to end the sub-series, I guess, of types. This is going to be the last type that we're going to talk about. So let's go ahead and open up a terminal here and jump into Python. Now, in the previous video, when we created a list, we used square brackets, and we entered a comma-separated values in there, which became our list. However, in order to create a dictionary, we're going to open up and close curly brackets here. Now, in a previous video, I told you guys that we don't use curly brackets in Python, and that was a lie. And just so you know, there's going to be a few of those throughout this course, so keep your eyes open for them. What I meant to say, and just to clarify, you don't wrap code blocks in curly brackets like you do in PHP and JavaScript. Instead, the only use that Python has for curly brackets is to define a dictionary. So rather than entering comma-separated values, we're going to enter comma-separated values, but each one of those is going to be a key and a value. So let's go ahead and create one. Let's create a person. So the name is going to be Nick. Age is going to be 27. And hobby is going to be code. And that becomes our dictionary. Now, again, you can, hold on. You can access, I try to do that the JavaScript way here, which you put a dot and then the name of the key that you're looking for. In Python, you do it like this, kind of like when you define an index number here. If you were to do this, it wouldn't be able to find it because it's not a list. But with an array, we would have done that. In here, we just type the name of the value we want. So name is going to print out Nick. If we put in age, that's going to print out 27. And if we entered hobby, that's going to print out code. And so that's how to define a dictionary and how to retrieve certain values from the dictionary. This is also going to become very useful later on once we get to once we get to JSON itself, because we are going to do a video on JSON, but also once we start working with a lot of data, some of it we're gonna explicitly convert into JSON data, just so we can parse it like this, because this is one of the easiest ways to parse data is using this format. So thanks for watching this video, and I hope you guys enjoyed it. This ends the subsection of types, and in the next video we're going to be learning about variables. Welcome back, everyone. Let's talk about variables now. Now, you can probably guess by the name, a variable is something that is variable, meaning that the name or the value of it is not always going to be constant. So by explicitly stating strings, they're not reusable as well. If I wanted to, say, let's jump into a Python console. All right. If I wanted to create a string, not using variables, this is a string, I could create that. However, there's no way now for me to reuse it to do something else. So I'd have to do this, is a string plus hello. And then there's no way for me to reuse that one. And so you can see the problem. Now that's one reason why we use variables, is so we can reuse the variables. Now another reason is because when you pass values into functions, it's going to take on the form of a variable through the parameter list of the function. We'll get more into functions later. Now the difference between Python and some other programming languages is some programming languages are typed. And you might say, well, hey, aren't all programming languages typed? Yes, you type them with your fingers on a keyboard. However, a typed language basically means that you need to define the type of variable. So as we learned in the previous videos, the different types are like integers, strings, booleans, and stuff like that. So if you were setting a string variable, you'd have to explicitly tell the program that it's a string. But with Python, you don't need to do that. All you need to do is give your variable a name and a value. So let's go ahead and let's create a variable called greeting. And it's going to equal a string that's going to say hello world. Now, you'll notice when I hit enter, it didn't print anything on the screen and it didn't do anything noticeable. And that's because setting a variable doesn't have any type of response. So it just creates a variable and it's there. Now we can use it by using greeting. So I could type print greeting, and it's going to print hello world. Now also, now that I've got it in a variable, we can manipulate that variable in a number of ways. So I'm going to type greeting equals greeting split. We're going to split it at the space, and we're going to set it to the first item. So basically what we're doing here, and I can't use double quotation or double equal sign there, we're setting greeting to a new value, which is going to be greeting, which we're going to split at the space. So we're going to split it right here, and we're going to get the first item in there. So it's going to turn greeting into just hello. Just hello. So let's hit enter here. We've assigned it a new value. So if we now go ahead and print greeting, you're going to see that it says hello. So now what we can do is now concatenate this with something else. So we can do that in a number of ways. We can reuse the previous example where we just well, let's just print it out first. We can print greeting plus a Nick, and it's going to say hello Nick. Now if we wanted to store that in a variable, we could do the same thing that we did before, or you can continue using this variable for different people. So I could say hello someone else. And so that's how that works. Now if I did want to make the greeting equal to concatenate a string, all you'd have to do is redefine it as greeting equals greeting plus Nick. And now when we print out greeting, you'll see that it says hello Nick. So that's a variable and the useful things that you can do with it. Now you can also assign values of other types. So we can say number is going to equal 1, and then second number is going to equal 2. So now we've got number and second number stored in variables. Let's do something with that. So what we're just going to do is add these two numbers together in a print statement. So print number times second number plus second number times number. And this is going to print out 4. So essentially what the print statement is doing is before it prints it out, it's calculating this because we've stored these as integers. And so it's going 1 times 2 plus 2 times 1. So it's essentially saying 1 times 2 plus 1 times 2, and it's coming out with this. So, and as well, you can set check equal to true. So that's how to set variables. It's pretty simple, and we're going to be doing a lot of this. So this is a concept that you're going to have to be very familiar with and get used to using it. In the next video, we're going to be talking about some built-in functions, and we've already actually talked about some of them. All right, guys, we are going to talk about some built-in functions before we move on, and then we're going to get on to defining our own functions and the different parts of a function. So let's go ahead and open up a terminal here. I want you guys to loosely follow what I'm doing here so that you guys can get used to using these functions, which I think we're going to be using some of them quite a bit, and you're going to be using some of them quite a bit once you're done this course. So these are some basic, very basic functions that we need to learn about. We're not going to go through any modules like the math module or anything like that. We're just going to go through a few basic functions. So let's jump into a Python console here, and we've already learned about a few, so they're just going to get a quick mention here. You can print out on the screen in the terminal whatever you want to, basically using the print command. You can convert things to a string using the str function, and you can do this for both integers and floating points, and actually booleans. You can convert that to string. And then for each of these types, you can also convert them to their own types if they are a string. So I can use int here, and it's going to convert that to an integer. I could use int like that, and float. I can use float to convert 5.6 to an actual number, and then you can perform mathematical operations on it if you want. Now, let's say we have a string like true, and we want to convert that to a boolean to actually be able to test things with it. What we do is type bool, and there we go. That's going to convert that to a boolean operator. Now, let's also talk about a command called len. Basically, what this is it's going to determine the length of something. So it can work with arrays and strings. So let's go ahead and try and figure out how long hello is, which means how many characters are in this, and there are 5. Now, this command can also be used on an array. So 1, 2, just a few random numbers in there, and it's 5 digits long. Now also, if you were to put strings in here, each with different number of characters, you would see that this is still going to be equal to the number of items and not the number of characters within each item. So that's how to calculate the length of an array. Now, another thing you can do with an array that's pretty neat is sort the array. So let's go ahead and create an array which is, let's say, we're going to put some random numbers in here in, no specific order. There. Now, as you can see, this is incredibly random, but let's say that we wanted to sort the array into lowest to highest, or first to last. What we would do is actually wrap it in a function called sorted. And this will shift around the array until all numbers are in ascending order. Now let's do the same with an array with strings instead. So let's create some letters here. Oh, couple issues with that line of code there. So it sorts it, but as you'll notice, the A is at the end. Well, why did that happen? If we were to capitalize it, the A would be at the beginning. So again, if we turn some of these letters into lowercase, which obviously come before other letters here, and one more, you can kind of see how it's working. The capital letters are parsed first because that's just the way it works, and then lowercase letters. And what if we threw a number in there? You'll see that it can't do that. So what you would have to do is wrap it in quotes, and let's throw another number right here, and a floating point wrapped in quotations. And you're going to see that the way this sorted is it put numbers first, regardless of if it's a floating point or integer type. They have to be wrapped in quotations in order to be sorted with other strings in an array. And then it parses the capital alphabet and then the lowercase alphabet. So that's kind of a priority order there. So just so you guys are aware of that. So what we're going to do next is actually explore functions. This was just a few basic built-in commands in Python that we are going to use through the rest of the course, and we're probably going to, well, we definitely are going to find other built-in functions as we move along as we need them. So let's get into functions. All right, guys, so let's get into functions. Now, every programming language basically has functions. I mean, they're going to be different depending on which programming language we're discussing. Even COBOL has functions, but they're radically different because that's just an entirely different language. However, basically, if you have any experience with PHP, JavaScript, functions are going to look a lot, very similar. So we are now past the need to use an interpreter, and what we're going to be doing from here on out is using our IDE that we have installed. Again, I want you guys to follow along, maybe even do some extra repetitions of this just to get used to it. So the first lesson here in the subsection of functions is going to be building a function. So pretty simple. We're going to build a function, we're going to call it, and we're going to run the script. So let's go ahead and drop down a couple lines. And also, we're going to go over some PEP guidelines throughout this course. We're probably going to have a module specifically for PEP, but as I go along and I see or think of anything that's addressed in the PEP guidelines, I'll let you know. So basically what PEP is Python's style guide. So it's like how to write certain things and certain, we always drop down 2 lines between any text or at the top of a script. So we would have our imports up there and then drop down 2 lines and then start coding. So we drop down 2 lines and we're going to, instead of typing function, we're going to type def. And what this is telling Python is that it's going to define a function. So we write def and then the name of the function. Now, regarding naming functions, there's a specific way to do it according to the PEP guidelines. This isn't new, this specific instance. It's using snake case for function names. So if you know camel case, that's basically like this, right? That's what that looks like. The first letter of each word is capitalized. That's used in Python for class names, but it's not used for functions. When you define a function in Python, you're encouraged to use snake case, which is separating words with underscores. So that's what we're going to do. So I'm going to create a function here called myFunction. So basically, so far, we've got def, which says we're about to define a function. We've got the name of our function, and then we've got brackets right here. And these brackets are going to be used for parameters, which we're going to be going over in one of the next videos. They're also called arguments. Now, after we do this, here's the point when in most programming languages, you'd open your curly braces and start to code. But instead, with Python, where we don't use those curly braces, we just put a colon here. Now, this is going to be smart. Python's smart because it's going to automatically determine when this function is complete based on indentation. So based on that, you can probably assume how we're supposed to use this, but we hit enter. You'll notice that it automatically indents 4 spaces in. And this is because anything 4 spaces in from the left-hand side, as of right now, is going to be the top level of this function. And then you can further indent stuff, and we're going to explore that as needed as we go on. So this is going to be just a very basic function that prints something out. So let's go ahead and print out, this is my function. And then we come down here, and we remove the indentation, telling the function that we're done. So now anything we write here is not considered inside that function. Now we could additionally put more in this function simply by doing that and writing more indented to the 4th space in. Now also with Python, this isn't something that I've mentioned yet, I don't think, but you don't need to end statements with a semicolon like in a lot of other programming languages. So just keep that in mind. So now we can drop down out of that function. Now we can call that function. So to call a function, you're just going to type the name of the function and then any parameters that you're going to pass in, which would go in these brackets. In this case, we're not going to put anything in these brackets because we're not passing in arguments. We're going to be going over that in the next video. Now actually you can see PEP 8, no new line at end of file, which means we need a new line at the end of file. And you'll see that the issue has been resolved. So PyCharm will kind of let you know if you're ignoring or just not using any PEP guidelines in your code. So let's go ahead and save this and let's go ahead and run. And as you'll see down here in the console, it first printed out, this is my function, and then it printed out a second string. So if we look up here at the code, again, we're going to go over the flow of this one more time. We're defining a function. We're naming the function myFunction so that we can call it by that name. And we're putting brackets here, which will contain arguments at some point. You don't have to. If your function doesn't take arguments and doesn't need outside information, just don't put anything in there. And then a colon, which starts the indented block of code on the next lines, which is indented 4 spaces. Now, I mentioned further indentation in a function like 8 spaces, 16 spaces. That's for each block of code. And that's not really something I can explain further. You guys are going to see it as we go on. So anyway, this is the function, because they're both indented to 4 lines, so Python knows that's inside the function. And then down here, outside the function, we're calling the function, making it print it out. So in the next video, we're going to talk about arguments and how to use those inside your function. All right, guys, welcome back. In this video, we're going to expand on this function here, and we're actually going to implement arguments into the function. So what this means is this is very static right now. Nothing would change this even if we wanted to change it. I could call this function, let's say 10 times, and each time it's going to print out very static strings. So how we can change this to make it more dynamic is by using arguments. And the arguments, again, go in the brackets here at the end of the function name. And what you're doing is creating a variable, so we don't even need to know the value that's being passed in. We just, let's decide to use two arguments here in this function, and each one is going to be used in its own print statement. So we're going to name it str1 and str2. There. And this basically we've abbreviated string1 and string2. It also tells us right now it's not being used. You're going to find PyCharm pretty smart. So what we're going to do is change this line of code to print out string1. Then we're going to use this print statement to print out str2. And let's go ahead and save it and run it. We're going to get an error. And the reason is because we're calling this function without passing anything into it. And it actually tells us right here, parameter string1 unfilled. So it knows that this function is looking for 2 values here separated by a comma. One of them is string1 and one of them is string2. We haven't passed anything into it. So it's calling this function, and immediately the function is freaking out saying, I can't find this information. So what we need to do is pass in 2 strings here, and how we do that is similar to how it looks in here, except each one is going to be the value and not the variable name. So the first one is going to be called this is argument 1, then make a comma. This is the second argument, which is also a string. Now if we save, go ahead and run, you're going to see that this is now printing out string1 as defined right here, and string2 as defined right here. So why would we need to do this? Well, let's say we're always going to want to print out 2 things. Let's go ahead and call the function again, but this time we're going to pass in different strings. Let's fall back to the good old hello world. Now we're going to save this, and what's going to happen is it's going to print out 4 lines. It's going to print out, this is argument 1, this is the second argument, which is being called from the first call of that function, and then stringy and hello world from the second call of that function. And so that's how to use arguments. Now, in the next video, we're going to be discussing keyword arguments and what those are. All right, guys, in this video, we're going to be talking about arguments a little further. We were going to move on to keyword arguments, but before we do that, it's going to make more sense to cover default arguments first. So let's go ahead. I've cleared out my script here. I suggest you guys do the same just for repetition. I mean, you could remodel your current function to work with this. However, repetition is the key to mastering something. So let's go ahead, drop down 2 lines, define a new function. We're going to name it print something. And it's going to take 2 parameters. One is going to be name and the other is going to be age. Now, let's open that with a colon and print out 1 string, which we're going to concatenate with name and age. So my name is name and my age is age. Simple enough. Now we're going to go down here and call this function. And my age is going to be 27. I'm sure you guys already see a problem with this. So I'll give you props for that, because this is not going to work. And that's exactly why I'm showing you. We're going to run it, and it's going to say that it can't convert int object to a string. Now, there's a few different resolutions to this. One I've already shown you. You can just wrap this in string. Now you can run it, and it will work. Now, this is why I mentioned this earlier, because you can definitely do this. However, what we're going to do is, instead of concatenating the string, we're going to remove all these extra characters. We're going to separate things by a comma. Going to remove the extra spaces around the text as well, because we don't need them, and you'll see why. Now, this will work without converting this integer to a string. And the reason is because when we use commas, it just says print out. It just says print out these four things, one after another. We don't need to concatenate different pieces of data. It's actually printing out a different number of things. So it's going to print this out as a string. It's going to print this out as a string because we're passing it in as a string. This is going to be printed out as a string, and this is going to be printed out as an integer. However, when I save it here and run it, you won't know the difference. See, it says my name is Nick and my age is 27. You don't notice that this is an int. So this is a perfectly acceptable way to do that. Now, what if I only wanted to pass it one argument? Well, what we can do there is we can create default arguments. So actually, let's pass in Nick. So let's go ahead and change these to accommodate only passing in some of the values. So what we're going to do is set a default value, and how you do that is inside the parameter list of the function, you're going to assign values to these variables. These are just variables that you're creating right here. So you can create a variable and assign a default name. And then same with age, you're going to assign a default age, which we're going to say is unknown. Now we're going to save it. Now when I run this, what we have here is my name is Nick and my age is unknown because I'm only passing in this. So what happens is you'd think, well, shouldn't name equal someone? It would if I didn't pass anything in, so we can do that as well. We're going to save this and run it, and it's going to say my name is someone and my age is unknown because we're not passing in anything. However, we're going to pass in the first argument here, and this is going to take priority over this value here. This basically means this variable is going to be equal to someone if no value is passed in. Age is going to be equal to unknown if no value is passed in for it. So that's how to use default arguments in functions. In the next video, we're going to be talking about passing in specific parameters by using keyword arguments. All right, guys, so let's talk about keyword arguments. In the last video, we found out how we can pass only one parameter into a function if we have the other one set up with the default value. So this will allow us to pass the first argument only. There's going to be no way to omit this and pass the age. So let's do this there, and let's run it. It's going to say my name is 27 and my age is unknown. Now, there is another keyword in Python called none, just like this. This would be a Boolean, I guess, or just a keyword in general. Basically, this is the equivalent to null in other languages. So we're going to save this and run this again. And it's going to say my name is none and my age is 27. There's literally no way to only pass in an argument that is not the first argument, unless you use keyword arguments. And that is defining what variable this is supposed to be. So if we do this and hit run, we're going to see that my name is someone because we didn't define a name, and my age is 27. Now we can also use this to pass in parameters in different orders. So I can say name is Nick. there. Let's save that and run it. And you'll see that the order we're passing it in, it should, if we weren't using keyword arguments, it would say my name is 27 and my age is Nick. So by using keyword arguments, we can specify which value is supposed to go into which variable when it goes into the function. So that was actually pretty quick. That's keyword arguments and how to use them. Kind of like the sister concept of default arguments. So in the next video, we're going to be talking about an infinite number of arguments. All right, guys, let's go ahead and talk about an infinite number of arguments being passed into a function. So what we're going to do is define a function called print people. And here's where we're going to pass in the arguments for a function, but we don't know how many we're going to get. We may get 3, we may get 100. So what we're going to do is start off, we're going to only pass one argument into this function, and that's going to begin with an asterisk. And this asterisk tells this argument that it's going to be an array of all of the arguments that are passed into the function. So you're going to see more how this works in a moment. Now, with an array, we need some way to loop over it, and so we're going to be using a for statement, and we're going to go more into this in the future. But for right now, all you need to know is you're going to write for person in people, and you're going to notice that when I drop down to the new line after putting the colon here, it further indented my code, which means what I'm writing here is going to be a different block. It's going to be one level deeper than right here. And that's, I'm not sure why that's underlining red, maybe because it's expecting me to type something here. So what I'm going to do is for person in people, I'm going to print out this person is person. There we go. So that's our function. We're done with that. Basically how a for loop works is this is a list or an array as we're defining right here. This is going to take in all of the values we're passing to this function and create a list called people. Now you can iterate over the people list by using a for statement. So for person in people, and this person can be any. You could write this for item in people. But where we are using the variable name person, that is going to be available in this block of code as the next person in the list. And so you guys are going to see how this works. Again, if you're familiar with other programming languages, this is not a new concept. It's just a slightly different way of doing it. So let's go ahead and call the function print people, and let's pass it some names. So Nick, Dan, Jack, a dog name, King, and let's say Smiley. I'm not even sure if this is a real person's name, but we're going to pass it into this function anyway. So what we're doing is we're passing in 1, 2, 3, 4, 5 arguments. Now, if we knew we were always going to expect 5 arguments, we could accept each individual argument as its own variable. However, we don't, so we're capturing all these. We're going to create an array out of them, and the array is going to be stored in the variable called people. So we're going to run this, and you're going to see that for each person, it prints out this person is, and then the name of the person. So that's how to include an infinite number or a flexible, like it's not really infinite eventually. If you were going to pass in an infinite amount of parameters, you would never be done your program. You could pass it on to your descendants, and they would never be done, and so on. This is truly a flexible number of arguments. So, with that being said, we're all done with that. In the next video, we're going to be discussing return values, and then we're going to build a calculator. All right, guys, this is the last video in the subsection for functions, and we're going to be talking about return values from functions. So again, this is not new to some of you. To some of you it is. So It's a pretty basic concept. Basically, in the past, we've created functions that do something, in which case each time the function was called, it printed something to the screen because inside that function, that's what we've done. We've told it to print. But what if we want to return a value from the function and don't want to print it out and then do something else with it? So let's go ahead and define a function. Let's call it doMath. And define two variables, num1 and num2. It's going to be a very simple function here. And we're going to return num1 plus num2. Now, if we call doMath and pass in 5 and 7 and save it, it's not going to do anything because we're not printing anything out, right? So what we could do is actually, let's create a variable called sum1, or rather math1. And this variable is going to include the sum of the two numbers that we pass in. So we're going to call it a second time as well. Pass it in 11 and 34. So we're going to save it. Now, when I run this function, or when I run this script, again, nothing happened because we haven't done anything with it yet. So what we're going to do now is print out both results in one print statement. So we're going to say first sum is math1, and the second sum is math2. So if we save this and hit the run button, you'll see that the first sum is 12 and the second sum is 45. So let's go over this again. So you guys, I'm not sure if I've explained it well enough, so I'm going to do that again. We're defining a function, we're calling it doMath, and we're passing in number 1 and number 2. So there's two arguments going into this function. Inside this block of code, we're only returning the sum of num1 and num2. So in the case of the first sum, it's going to be 12. So we are returning to whatever part in our code we're at. So this is going to become 12. So math1 is equal to 12. And then math2, we're going to call that function again. We're going to pass 11 and 34 in. And again, it's going to return to this spot right here with the value that we tell it to return with. So this line of code right here is going to become 45. So math2 equals 45. Then what we do, we just print it out. And math1 knows that it's 45 because that's what the result of that function is. And so this is going to be useful for a lot of reasons later on in programming. So in the next video, we're going to create a calculator using Python, and it's going to be a command line tool. So we'll be able to run it and perform different math operations. All right, guys, now we're going to be learning about some conditional statements in Python. So we're going to be learning about the if-else statement. And this basically provides a way to evaluate if something is true or false, or if something is something or it's not something, and do something different based on which condition is true. So let's go ahead and let's set check to false. And what we're going to do with that is we're going to say if check equals false, print it is false. And I'm going to save this, and this is the minimal you need for an if statement. We're going to go ahead and run this, and it's going to say it is false because it is false. Now if we were to change this to true and run the same code, it's not going to do anything. And that's because we haven't provided an else. So if it's equal to false, it will do this. Otherwise, it's just going to do nothing. So let's go ahead and drop back 4 spaces to where the if statement began, I guess, and then type else. and we're going to print it is actually equal to true. So let's go ahead and let's run the script. And you'll see that now, where this is not the case, check is not equal to false, so then it's going to do this instead. Now, what we're going to do is, this is good if you want two conditions, but what if you want more than two conditions? Between the if and the else, you can actually use something called elif. And here, we actually need to supply a condition to the elif. So think of it like another level to the if statement. And think of the else as a catch-all. Like if none of the above are true, then just do this. So if check equals false, it's going to do that. Elif check equals hamburger. We're going to print out yum hamburgers. And let's throw another elif in there. Let's say print hello. So let's go ahead and save this. We're going to run it again. And as you can see, check is equal to true. So it says, is this true? Nope, move on. Is this true? Nope, move on. Is this true? No, move on. Okay, well the else is going to say, well, if none of the above was true, then we're just going to do this. So what we're going to do right now is we're going to set this to hamburger. And we're going to run the script. And you'll see what's happening is it's checking this one first. That's not true, so it moves on. It's like, okay, this one's true, so let's just do this, and then let's get out of the if statement. So it doesn't check any further. So that's what an if statement is in Python, and that's necessary for what we are about to do. All right, guys, so we are about to create a calculator program in Python. And before we do that, actually, we need to learn a few more things. So we're going to go over a couple of the loop types in Python. So there's two. One of them is a for loop, and one of them is a while loop. So basically, a for loop is good for if you want to iterate over an array or a list in Python. You can do something for each item in the list. So let's go ahead and create a list. So let's just call it numbers. And we're going to create an array and go 1, 2, 3, 4, 5. So let's type for item in numbers. And we're going to just print out item. I'm going to save. And let's go ahead and run this. And you're going to see that on each line it prints out its number. So we would be able to do this if we wanted to have different names in here. So again, let's go Nick, someone, another person. Save this. Let's go ahead and run the script again. And it's going to print out Nick, someone, and another person. So what we can do here actually is we can type this person's name is, and then the name of the person. So let's go ahead, and you'll see that for each one it does print out that. So that is a for loop, and basically the second parameter here in the for loop is the array or the list. And then the first one here is what you want each item in the list to be called while inside its little block of code. So in this case, we're calling it item. So that is a for loop. Now we're going to learn about a while loop. So let's go ahead and create two variables. One is going to be called run, and it's going to be equal to true. And the other is going to be called current, and it's going to be equal to 0. Actually 1. So let's go ahead. And what we're going to do is type while run, and then we write what we want to happen if it's currently running. So what we're going to do is we are going to put an if statement here. So we're going to go if current equals 100. And I actually don't need those brackets. All right, so if current equals 100, we are going to set run to false. But if it's not, we're going to print current. And then after we print current, we go current plus equals 1. So let's go ahead and save this. And what this is going to do is basically we're setting run to true initially because we want it to run at least once. So while run, which in this case the first time it goes over, it's definitely going to be true, it's going to check, is current equal to 100? Well, on the first time, no, it's not. It's equal to 1. So this block of code won't run. If it's not equal to 100, what it's going to do is it's going to print the current number and then add 1 to the current number, and then run is still true, so it's going to go over it again. So what we should see here is it's going to print the numbers 1 to 99. So let's go ahead and run the script, and that's exactly what we see here. Now, these are two useful concepts that we're going to be using, so hold on to those. And if you didn't quite understand what I'm doing here, let me know in the discussion section. Hey guys, what we're going to do in this video is learn how to import different modules into a Python script, and we're going to learn about regex. So what's a module? Basically, it's an external library that you can include and use in your project, providing additional functionality without you having to write this additional functionality. So for example, we are going to go ahead and import re, which is the regex library. And that's how you import something. Just type import and the name of it. Now, re is included with Python, and so there's nothing that we need to install in order to use it. So now the basic usage, well, let's get into regex. So I'm going to go ahead and create a string, and it's going to say, I am not yelling, she said, though we knew it to not be true. Now, basically, regex is not part of Python. It's kind of like a mini programming language that you can use in basically any programming language. So, I mean, you can use regex in Python, in PHP, in JavaScript, Java, C++. So, regex is basically a way to match certain characters and then do something based on that. Now, as you can see on Wikipedia here, there's standard libraries for .NET, Java, Python, C++, and there's some built-in for Perl, JavaScript, etc. So this is not Python specific, and we're only going to cover it to a limited degree as we need it. So in this instance, we're going to be learning a few things for in the next video. So let's go ahead and start figuring out how to use regex. So the first thing we're going to do is, if I print string, you're going to see it says, I am not yelling, she said, though we knew it to not be true. So we've got capitals, lowercase, we've got a period, comma, and quotations. So let's go ahead and play around with this a bit. So I'm going to create a new variable called new, and it's going to be equal to re.sub. And what we're doing is we're instantiating the re object that we imported at the top of the script, and we're calling the sub or substitute function on the re object, which the sub is built in to the re object. So just like calling any other function, when you call a function on an object, you need to put the parameters into the parameter list. Now, we haven't discussed classes and objects yet, and we're going to get to that, but this is, we need to know this for the sake of this video and the next one. Now, the three parameters that this substitute function takes is the matches that we want to make, what we want to replace them with, and then the string that we're going to manipulate by doing this. So we've already got the string stored in the variable named string. Let's go ahead and cover some matches. So let's say we want to remove all the capital letters So what we're going to do is basically open and close square brackets. Now, rules in regex are contained within square brackets. So if we wanted to remove all the capital letters, I mean, we could go A, B, C, D, E, F, G, H, we could do it that way and list out the entire alphabet, but regex actually provides a way to not have to do that by allowing us to choose a range of letters. So this is going to say any capital letter from A to Z we want to replace with nothing, and we want it to do this on the string. So let's go ahead and hit enter. Now if I print out new, you're going to see that it removed all the capital letters and left everything else intact just the way it is. So we could also do the same for lowercase letters. So instead of removing all the capital letters, it's leaving everything except the lowercase letters. Well, let's say we want to remove all the special characters. So what we can do is actually we can put multiple rules inside of the square brackets. So let's go ahead and put period, comma, and then let's backslash to escape this quote. And let's hit enter, print it out. You'll see that it removed all the punctuation from our string. Now let's go ahead and combine this with the lowercase letters, and then additionally uppercase letters. We're left with nothing except the spaces. You can't see them here, but there are spaces here. Let's go ahead and leave the lowercase letters just so you guys can see. There are spaces. So there's about 4 right there, and so we've got spaces. So let's remove the spaces as well. How we're going to do that is within here, put a plus sign, and then we're going to open up quotations and put an empty space, and then close the quotations. Now let's go ahead and let's add actually. So let's go string equals string plus that. And then let's print out string. And what you can do as well, you can actually create new equals re.7. What we're going to do here is we're just going to tell it to remove anything except numbers. We actually need to put that in quotations. We're going to replace anything that's not numbers with nothing, and we're going to perform that on the string. So now if I print out new, you're going to see that all that remains is the numbers. So that's the extent to which we need to learn regex in order to do what we're doing in the next video, which is building an awesome calculator. All right, guys, welcome back. We are at the end of the second section for this course, which means you guys have a basic understanding of Python. You actually have enough right now to build some basic programs. Now, you might be thinking, well, hold on, we didn't even do that much. That might seem like it's true, but we've learned some core principles and concepts here, as well as the language syntax so far. So we currently know how to create loops like while and if, or while and for loops. We know the if-else statement. We know how to create strings and all the different types like booleans and numbers, and we also know how to set variables, among some other stuff. So what we're going to do right now is, for the project for this section, we're going to put most of what we've learned in this section, and we're going to build a calculator program. So I'm going to open up Chrome here, and we're just going to search Python calculator and just calculator, just to see basically how we might write a calculator. So this looks good. So as you can see in the top of the script, they're defining 4 functions, one for addition, subtraction, etc. And each one of them is going to take a limit of 2 numbers, and it's going to return the result of the chosen mathematical equation between the 2 numbers. So that's going to be the same for multiply, divide, and everything. And here's where the actual program is going to start to output and input. So basically it's going to say select an operation, and it's going to tell you what each number is equal to. And then it's going to create a variable called choice, and it's going to use an input function, which basically allows the user to type something and then hit enter, and whatever they type is going to be stored in choice. So this is going to be the prompt. So this is going to print out before the input. So basically it's going to say enter choice 1, 2, 3, or 4, and then whatever the user types after that becomes it's going to be stored in the variable choice. And then they're creating 2 other variables, the first number and the second number, and for each it's going to ask you to enter the number. So first you enter the type of math you're going to be doing, and then you enter the first number, and then you enter the second number. And once you hit enter here, what it's going to do, it's got everything it needs, so it's going to use an if-else statement to determine what your choice was, so that it knows what function to call with the 2 numbers that you've put in, which is awesome. And you guys might be really excited to build this, but we're actually going to go a few steps further. And the reason is, if we open up a calculator, you're probably going to know that I wasn't asked right off the bat what mathematical operation I want to perform. It just loads up with the number 0. And then I can type a number, so let's say 50, and then the mathematical operator, which we're going to use multiply, and then 2. We're going to hit enter, and we're going to get 100. Now, with the ending of the math equation here, you'll notice 2 differences between this program and the Python script in the background there. And that's that it didn't quit, and actually we can continue to operate on the result of that first equation. If I want to add a 75, I'm going to hit plus 75 and enter, and it's going to add it to the result. Now if I want to multiply that by 2, I just hit times 2, and it's going to multiply that. So this is a continuous mathematical operation where the Python script allows you to perform one operation and is limited to 2 numbers, and it's very non-efficient and I guess very simple. So that's good, but we're going to go a little more advanced. So go ahead and open your IDE. What we're going to do here is we are going to be using the regex library. So we're going to import regex. And then we're going to print out the name of our program, which is going to be called our magical calculator. Now, right off the bat, we're going to create 2 variables. So previous is going to be equal to 0. And what this is going to do is the previous variable is going to hold the result of the previously calculated equation. So we're going to set it to 0 because we haven't done any math yet. And then we're going to create a variable called run. And you guys can probably guess what this is going to do. Now, we need to create a loop for our program, so we're going to type while run, and we're just going to call a function called perform math. So let's go up here and create a function called perform math. So the first thing we need to do is be able to accept input from the user to type in something. So let's go ahead and type equation equals input, enter equation. And for now, we're just going to print out whatever they typed. So let's go with you typed equation. Let's hit save. Now let's run this. So I'm just going to print hello world, and it says you've typed hello world, and then it drops back into the prompt. So I'm going to type again, typing something. And this is going to loop forever because we haven't created a way to stop it other than, closing the terminal window or hitting stop right here. So what we're going to do now is create a way to end or quit out of this application. So let's go ahead and print out type quit to exit, followed by a new line. So let's save that. Now what we need to be able to do is if they type quit, we want to be able to actually quit out of the program. So what we need to do is we need access to the run variable in here. So for example, let me just do this first. If equation equals quit, let's go ahead and set run to false, else print out whatever we typed. So go ahead and save, and we're going to run this. So we can type hello, and what it's doing is this, we didn't type in quit, so it's not doing this. Instead, it's doing this. So let's type in quit, and it's not doing anything. So basically what's happening here is this is variable scope. Basically, to explain this, this is a variable we created in the top level of our program. So not defined in any functions or anything. We are in a function here, and we're in an if statement, so we're further into the code, and we've stated run equals false. Now this is not going to have any effect on this variable. It doesn't have access to it. So what we need to do first is actually get that global variable into this function. The way we do that is just at the top of the function, type global, and then the name of the global variable you're trying to get access to. So let's go ahead and save and restart. So you'll see we can still type in stuff, but as soon as I type quit, it actually exits. So that's what we want it to do. Now let's go ahead and restart this. We're expecting equations to look like this. So how can we do that? Well, let's actually, how can we do that without creating a limiting set of functions that will perform operations? What if we wanted to do this? Or what if we wanted to do this? In the script that we just looked at, this wouldn't be possible because we can only use two numbers, and they're each collected in their own variable. So what we're going to do is we are going to use a built-in function. So actually what I'm going to do is grab access to the previous global variable as well. I'm going to set previous here equal to equation. And then if we go ahead and rerun this, well, we see it still says you've typed 82, or you've typed, whatever the equation was. So we want this to perform math, and what we're going to do is we're going to use a built-in function called eval. So let's go ahead and type that here, eval, and then let's save, let's restart. And you're going to see that before it prints out the result, or whatever we've put in, it's going to evaluate it. And so this is going to be able to perform complex mathematical operations from strings. So we can literally type in 80 times 100 plus 42, take away 10 plus 78 times 142. We hit enter, and it calculates that up. and it does it in the correct order. So we all know that multiplication happens before addition, and the evaluate statement or function actually is aware of that, and it does that for us. You might be thinking, well, that's awesome. Why don't, in those basic calculator examples, why don't they just use the eval function? And the reason is because the eval function is actually supposed to be avoided because it can be dangerous. So let me show you why. I'm going to print out here, hello world, and hit enter. And you'll see what happened is when it evaluates, and actually, if we type in Python code here, it's going to execute that. So let me go ahead and set global run. See, so we can actually crash it as well. Now, this is going to work as long as we assume that our users are going to be performing math equations, but what if they're not? Well, because of this, we're actually going to do this. So let me go ahead. And equation is going to be equal to the evaluation of equation. Or actually, hold on. Oh, previous, okay. So what we need to do first is perform some regex on it. So we want them to only be entering, mathematical symbols or numbers. We don't want them to be able to type anything or to issue commands. So the way we do that is basically let's create a new variable, or actually let's assign equation equal to re.sub. And here we're going to be entering our regex. So for the sake of this, what we're going to be doing is A to Z, capital A to Z, and then let's say comma, periods, brackets, and spaces. So there we go. So we're going to remove everything except, everything important. Let's actually go ahead and also remove the colons. We're going to replace it with nothing. We're going to do this to equation. So let me go ahead and show you what I mean. So we're going to rerun this, and I'm going to say, hello, 6, world. What happens is it's going to strip everything out of that before it evaluates it. So it's only going to accept numbers or, as you can see, the plus symbol. Oh, sorry, plus right there. Let me remove that. All right. There you go. So 5 plus 11 times 2 is 27. Because 11 times 2 is 22, plus 5 equals 7. So we've already got an awesome calculator, but it doesn't look quite right. So what we're going to do is we're basically just going to put an if statement. It's only going to ask for you to enter equation if there's no previous. So what we're going to do is if actually create equation here. We're going to go ahead and say if previous is, let's just say equals 0. It's going to input that. Otherwise, equation is going to be equal to input just the previous. So I'm going to convert it to a string. There we go. So let me go ahead, and the first time it's going to ask for an equation, so 4 plus 3, and then it's going to drop down, and we can go -1, and you'll see that it doesn't quite work. So what we need to do is we need to tell it if it is, let me separate this here. There. We want to evaluate it separately if it's if there's a previous result or not. So what we need to do is let's go ahead and if previous equals 0, we're actually going to do this, which is going to only evaluate whatever we type in. Else previous is going to be equal to evaluate. I'm going to convert it to string. Previous plus equation. So let's go ahead and save. Restart. We're going to go 4 plus 4 equals 8. Take away 2 is going to be 6. Times 10 is going to be 60. And you can see that we're actually using different types of math on it. So 6 plus 5, take away 2 plus 3, 66. So this is what we want, but let's just remove where it says U typed, because we no longer need that. Three take away 2 is 1 plus 56. And you can see that now we can really get into the math here. You can even type, oh, hold on, let me start that again. So you can perform basically any mathematical operation here. Then when you're done, just hit quit. Now we wanted to give a specific message when it quits. So let's just drop down here and have it print out goodbye human. Let's go ahead and run it, and when we type quit, you'll see now it says goodbye human, and then it closes. So this is actually a completely valid program, and it looks a lot different from the other example that we looked at. Now the eval function can be dangerous, okay? It very well can be. And that's why what we're doing before we evaluate anything is we're making sure there's no letters and there's none of these characters in it. Because if there were, you know, somebody could, let me open up this here. I can't do that, okay. Somebody could, you know, if they import the system and the OS modules that are included in Python, they could end up damaging their system. And so by using regex to remove all that before it's evaluated, we're keeping things safe. So thank you guys for joining me, and congratulations on finishing the second section of this course. In the next section, in the next bunch of videos, we're going to be learning more advanced concepts, and we're going to be developing more complicated programs than this.
Thank you very much for finishing all of the lectures about Python in this video. I'm really impressed you've made it this far in the video, because I've rarely finished a video this long in my life. You have a great attention span, a great dedication to learning. Either that or you skipped ahead straight to the calculator project and you're here now. Either way, I'm honored you're here with me, and I think if you've enjoyed this much of the video, you've got a really good chance at enjoying and getting a lot more out of the paid course. There's 3 times as much more information in the paid course as there is in this video. And if you've managed 2 hours of this, I'm going to guess you really like the rest of it. Now, if you go to my website, you can grab the paid course for $9 here. What you do, you hit add to cart, and then you go through and check out. You can use a credit card, PayPal, or you can even pay with Bitcoin. Once you've bought the course on my website, then you get a free coupon to enroll and take the course wherever it is currently hosted. And then you have the ability to get in the course. You then will get answers to your questions from Nick directly. Or if the course goes crazy as some of the other ones are, paid support staff who help Nick answer the questions. And for $9, you can get 3 times as much as you've already watched. If you want even more value, you can get hundreds of times as much for just $10 a month. I realize that might be a lot in some places in the world. Still, relative to all the cost of education, $10 is very low for the cost of a professional education that's really useful. I'm trying a new strategy of creating everything I do, all the things I know about, for free online, and then collaborating with other instructors to bring you more free videos like this Python video here with Nick. When you become a patron, you'll help me be able to continue to bring you more free videos just like this. You'll essentially be hiring me to keep making these videos for you so that you can learn for free, and then I'll give you as my thank you access to all my other courses. I've also got lots of other options. You can get a shout out. I'll make a new video for you specifically. You can get e-coaching, ad campaign setups, one-on-one calls, and I even have a sponsor level as well. I'm honored you're here with me today, and I don't know if you'll like the paid course or not. Honestly, it might be really good for you. It might also be a waste of your time. I don't know. That's real with you. I am grateful you've spent so much time in this video. I also have a daily podcast you might really enjoy where I try and do an inspirational monologue every day for 10 to 20 minutes. And today I just did one on comfort with uncertainty as a superpower. So this is 100% free too. This is on my website at jerrybanfield.com, and you just click on the podcast link. You can also search for Jerry Banfield on iTunes, or you can search for, I think the podcast is called Happier People now. So I think this is totally for free. You might enjoy this. You should be able to access this anywhere in the world as well. I'm honored you've spent so much time with me here. I hope this video's been really helpful for you. My mission is to make happier people. I think happier people in life, if you look from my Patreon page here, I think educated, inspired, and comfortable people are consistently the happiest people on earth. I'm continuing forward in my life today to do my best to be of service to you here. You can get more on my website and see everything else I'm doing. And if you want the Python course, just scroll down, find that yellow thumbnail for the complete Python 3 course, and I think you might really enjoy it, plus get answers to your questions. I could be wrong, though. I'm honored you spent so much time with me, and I hope you have a great day today.